Alright, so two figures are said to be congruent if all pairs of corresponding sides are congruent and if all pairs of corresponding angles are congruent. Okay, so if I tell you here that these two triangles are congruent, that means that corresponding sides and corresponding angles are also congruent. So if I say triangle ABC is congruent to triangle DEF. And it's that order, and I know it's that order because these two are marked the same, so angle A and angle B must be the same. These two are marked the same, so angle B and angle E are the same. And these two are marked the same, so C is congruent to F. So if triangle ABC is congruent to triangle DEF, then we know all of those things. Angle A to angle D, angle B is congruent to angle E, angle C is congruent to angle F. We also know the sides are congruent. Side AB is congruent to side DE. Side BC is congruent to EF. And AC is congruent to DF. They have to be in the right spots in the statement. So since A and B are the first two letters here, it has to be congruent to DE. And you can look at the figure and see how they're marked. A, B, and DE are marked the same. So if you have congruent triangles, you have 6 pairs of congruent parts. Now we don't even actually have to have the picture to know all the congruent parts. I don't have a picture here, but if I know that triangle Joe is congruent to triangle Max, I know that angle J is congruent to angle M. It has to be because they're the first letter in each one. I know that angle A is congruent to angle O. They're the second letter in each one. And I know that angle E is congruent to angle X. I also know that side JO is congruent to MA. I know that OE is congruent to AX, and I know that JE is congruent to MX. It has to be those because of the way the statement is written. It has to be the ones in the same spot in the statement. Okay, and when you're naming congruent triangles, you have to be careful of that as well. Now, it doesn't apply to just triangles, okay? It applies to all polygons. If the polygons are congruent, then all the corresponding parts are congruent. So, like for instance here, if I want to solve for x and for y. So x is in this algebra here, side LH. Since that's over here, the last two letters, it has to be the same as CD. It has to be the 9. So I could set 4x minus 3 equal to 9 and solve for x. Add 3 to both sides and divide by 4. For y, it's here at angle K, and from this statement I know that angle K has to be the same as angle A because it's the first letter. So there's extra information on this picture, but to know which one it is, I look at that statement. So 5y minus 12 has to equal 113. When I add 12 to both sides, I get 125. When I divide by 5, I get 25. I've solved for x and y. But it's about placement in that statement. So in triangle ABC is congruent to PQR. Again, solve for x and y. So angle P has to go with angle A. So I know to set that equal to 85. 10x plus 5 equals 85. Subtract 5 from both sides and divide by 10. Now doing y, it is Q Q goes with B, so this is the right one. Now if it wasn't, I could have figured this one out. If it was, and I needed that one, I'd subtract from 180. But I know that the 6y minus 4 has to equal 50. And so divide by 6, y equals 9. Congruent parts. So now, like looking at these diagrams, I've got my congruent statement here so I can figure out what goes with what. First thing I see, because it's up here on top, is that one's got x's and y's in it. So I don't really like that one because it's harder to solve an equation with two variables. You need a system of equations. But this one here only has y's, so let's see if we can deal with that one. So that's at angle O, so angle O has to go with angle P in the other triangle, which is this one. When they're twisted around and flipped and stuff, it's kind of hard to tell by looks. You got to go by that statement. So the 6y minus 14 has to equal 40. When I add 14 to both sides, my pen is not cooperating today, then y equals 9. Okay. Now, here's what I can do. Now I can replace this y with a 9, and 2 times 9 is 18. I can just make that x minus 18 instead of x minus 2y. And that is on segment NG. So since those are the first two letters on that one, I have to give the first two letters on this one, and it goes with the IT. So the x minus 18 has to equal the 7.5. I add 18 to both sides, x equals 25.5. Okay, so there's lots of extra information on the pictures, so you really have to pay attention to the statement to make sure you add the right things and set the right things equal to each other. So the third angles theorem basically just says if two angles of one triangle are congruent to two angles of another, not working very well, then their third angles are congruent. Okay, so I've got two different triangles, and so if I know that these two green ones are congruent, and I know that this angle is congruent to this one. Okay, so I can give these names. I guess I can make this, triangle cat, and we'll make this one triangle dog. Just be careful. Okay. If we had to write the statement, then my conclusion can be that angle T must also be congruent to angle O. Okay, now if I had to write the congruent statement, so be super careful here. If I have to write the congruent statement, I have to write that, especially when they use words for the letters, the things that make words. But which one actually goes with C? The one that goes with C is G, so that has to go next. The one that goes with A is D. It has to be GDO. If I do cat, then it has to be GDO. If I said BOG over here, okay, well, D goes with A, O goes with T, and G goes with C. That's another way. Either of those is fine, but you have to make sure if you're writing those statements that you put things in the right order. Very important. Okay, so just some more. You got to pay attention to what's congruent here. Be careful because, these two are congruent by the markings, and those two are congruent, but the one with the algebra in it is this one. Okay, so that's got to be congruent to this one by that third angles theorem. Well, how big is that? What do we set 4x plus 15 equal to? Well, triangles have to add up to 180. So between these two, that's 109. So 180 minus 109 is 71. So I'm going to set that equal to 71. Subtract 15, that's going to be 56. And divide by 4. Okay, so be very careful what you're setting it equal to. Here on this next problem, this one is equal to this one. That one's pretty straightforward. 2x plus 18 is equal to 52. When I subtract 18, it's going to be 34 divided by 2, 17. But what do we set 3y plus 11 equal to? You can kind of use that corollary. If one is 90, then the other two have to add up to 90, so this one's going to have to be 38. These two would be 38. It's 90 minus 52. 90 minus 52 would be 38. So we'll set that equal to 38. We're going to subtract the 11 from both sides and divide by 3. Okay, so just using the idea is that correspondings are congruent. So now we have some postulates about proving that two triangles are congruent. We don't need to know all 6 pieces of information, like up with Triangle Joe and Triangle Max. We don't have to know all 6 of those things to know that two triangles are congruent. So now we're kind of going the other direction. First I'm telling you, hey, these are congruent. That means this happens. How much information do we need so that we know two triangles are congruent? So the first theorem here is the side angle side theorem. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the sides are congruent. So if this pair of sides is congruent and this pair of sides is congruent, and it says and the included angle. Included means in between, so we'd have to be talking about this angle if we're talking about those two pairs of sides. That's enough information to know that the triangles are congruent. So we have side angle side for congruence. Okay, everything else would fall into place if we have that proper information. Okay, but it's got to be two pairs of sides and the included angle. Now, if it's two pairs of angles and the included side, two angles and the included side of one triangle are congruent to two angles and the included side of another. And that's to draw them exactly in the same spot. So let's say this angle and this angle are congruent, and let's say this angle and this angle are congruent. So angle, side, angle, so it has to be the included side. So the side in between those two angles, it'd have to be this pair of sides. And then we would know those two triangles are congruent. That's enough information to know that. Okay? So we have side, side, and we have angle, side, angle. A third way is side, side, side. If you know that all 3 pairs of corresponding sides are congruent, the angles will fall into place. Okay, I feel like I always draw triangles exactly the same way. I'm drawing random triangles. If I know these are congruent, if I know these are congruent, and if I know these are congruent, then the triangles are congruent. The angles will fall into place if the 3 pairs of sides are all congruent. So if we need to know very quickly here if these are congruent, we would say these are, yes, these are congruent by angle, side, angle, angle, side, angle. And if I had to write out the statement, it would be triangle if I go with cat. Here we go again. So C has to go with O, A has to go with D, whoops, there was the A again, and T has to go with G, and I forgot the triangle. Okay, I have to pause here and start a new one in just a minute. So